Hello everyone and welcome back to the GCSE Maths Series. Today we're going to be coming at you with exam style questions for our parallel and perpendicular lines topic. So let's get straight into it. So the question tells us to find the equation of the line parallel to 2x plus 5 equals to 10, and it passes through the coordinates 0 and minus 3. First things first, we need to rearrange our formula into the form y equals mx plus c. To do this, we rewrite it as 2x plus 5y is equal to 10. We move 2x onto the other side, so we have y by itself, so we have 10 minus 2x. We then notice that y is being times by 5, so we need to reverse this. To divide through by 5, we get y is equal to 2 minus 2/5 x. To get this in the form, y is equal to mx plus c, we just move around our x and our number. So we get y is equal to negative 2/5 x plus 2. And therefore our gradient is negative 2/5 x. So when our lines are parallel, our gradients are equivalent. So the general form for our line is y is equal to negative 2/5 x plus c. Using our coordinates x and y, we can plug values in to obtain 3 minus 3 is equal to negative 2/5 times by 0 plus c. Then simplifying this, we get c is equal to negative 3. So our equation of our line, when we plug in our value of c, is y equals negative 2/5 x minus 3. So moving on to the next question, we're told that line A passes through points 1, 5 and 5, 7. Find the equation of the line perpendicular to A that passes through minus 1, 7. So the first thing we're going to need to do is work out the gradient of our line A. The formula for gradient is equal to y2 minus y1 over x2 minus x1. So we label our coordinates as following: x1, y1, x2, y2. So then this is equal to 7 minus 5 over 5 minus 1, which is going to give us 2 over 4, meaning the gradient is half. Now, to find an equation of the line perpendicular to A, we now need to apply the negative reciprocal. And the negative reciprocal means to first reciprocal. So we take our gradient function, times it by minus 1. This is our negative part, so we get minus a half. Then we apply the reciprocal, meaning we put 1 over our gradient. So 1 over negative a half is equal to negative 2. And the way this is done is 1 divided by negative a half. We change this, flip this fraction, and we get 1 times by negative 2. So our gradient there is negative 2. Now, looking at our equation, we have that the gradient is equal to negative 2x. So now we have our generic equation for our line perpendicular to A. We use our coordinates that it passes through and label them x and y. And now we substitute these two values in to our formula. And we get 7 is equal to negative 2. Plug in our value for x and we get minus 1 plus c. So 7 is equal to 2 plus c. So c is equal to 5. Now our finished equation is y is equal to negative 2x plus 5. Moving on to question number 16, line A passes through the points 2, 1 and 5, 10. Line B passes through the points 4, 7 and 2, 1, and we need to show that the line A and line B are parallel. So as soon as you see this, alarm bell should be ringing, and we should say we need to prove that the gradients are equal. So we first do this by working out the gradient of A. So we do x1, x1, y1, x2, y2. And the gradient is given by y2 minus y1 over x2 minus x1, which is going to be equal to 10 minus 1 over 5 minus 2, which is going to give us 9 over 3, meaning the gradient is equal to 3. Looking at the gradient for line B, we have that y2 minus y1 over x2 minus x1. In this case, we're going to get 1 minus 7 divided by 2 minus 4, which is going to give us 1 minus 6 is going to give us 1 minus 7 is going to give us minus 6, and 2 minus 4 is going to give us minus 2. Therefore, our gradient is also 3. So, therefore, gradients are equal, so lines are parallel. Moving on to the last question today, we're told that line A passes through the points minus 3, minus 1, and line B passes through the points minus 2, 1, and K4. Line A and line B are perpendicular, so we know that the gradients are negative reciprocals of each other. So, first things first, we need to work out the gradient of A because we know all the information we need. So, labeling this, we have x1, y1, x2, y2, and the gradient is going to be y2, 9, minus y1, and then we're going to have x2, which is minus 1, minus our x1. So, we're going to have 10 over minus 1 plus 3 is going to be 2, so our gradient function is 5. Now, line A and line B are perpendicular, remember, so we're going to have to find the negative reciprocal of our 5. So first, timesing by negative 1 to make it negative, we're going to get negative 5. Then the reciprocal is going to be negative 1 over 5. Okay, so our perpendicular gradient is going to be equal to negative a fifth. So our general formula is going to be negative a fifth x plus c. Now, we can equate our line B gradient to negative a fifth. So we know that the gradient function, when we apply the formula, is going to equal negative a fifth. So negative a fifth is equal to our y2 minus y1 over x2 minus x1. So minus 1/5 in the case of line B is equal to 4 minus 1 divided by k minus minus 2. So minus 1/5 is equal to 3 over k plus 2. Now this is manipulation of formula and changing the subject of the formula. So timesing through by k plus 2, we're going to get minus 1/5 k plus 2 is equal to 3. Now, to get rid of this minus a fifth on the left-hand side, we're going to times through by 5 on both sides. So we're going to get minus k plus 2 is equal to 15. Then to get rid of our minus sign, we're going to times through by minus 1 to get k plus 2 is equal to negative 15. Then to get k on its own, we're going to minus 2 from both sides to get k is equal to minus 17. And that is our final answer. Okay, that's going to conclude today's video. As always, please make sure to like, comment, and subscribe. And I'll catch you guys in the next video. Peace.